Let's look at another example. Let's look at example 2. It says solve the linear system. So we have 4x plus 2y equals 2, 5x minus y equals negative 8. And we're going to use the method of elimination. You may be wondering by now, can we use the method of substitution? And the answer is yes. Right? You can use either method, right? Substitution or elimination, but it just happens that sometimes one method is better than the other. Since we are explaining a method of elimination, let's use the method of elimination for this one. Okay, so just like before, you try to eliminate one of the variables and by either adding or subtracting the equations. Now if you add these, we get 9x, right? Or and if you subtract them, you get negative 1x. So that doesn't work. And the same here, right? If you add them, you cannot really eliminate y, and if you subtract them, the same thing, right? So what do we do in this case scenario? Well, what we can do is, let me label the equations first, but what we can do first is we can multiply. Sometimes we need to multiply or divide one of the equations in order before we eliminate one of the variables. So in this case we can multiply, right? Sometimes you may have to divide, but in this case we multiply. So for example, if we had a 2 here, we could use subtraction afterwards to eliminate that, right? So, in fact, let's write this down. Okay, so once again, sometimes we need to multiply or divide one of the variables, one of the equations before eliminating one of the variables. Okay, so let's do that. We said we were going to multiply equation 2 by 2. So let me show you that. So we multiply this by 2 and we get, so 2 times this. So we're going to get a new equation 2. Basically, let's write this down as new equation 2. Let me move this up a little more. Good. New equation 2. So that means we get the following. So 2 times 5x, that gives us 10x minus 2y minus 16. Okay, so now we can do the following. Let me rewrite the equation 1 again. So we had 4x plus 2y equals 2. And we also have our new equation 2. Right? Let me just put a little star, just indicating that it's the new equation 2. But essentially it's the same equation. It's just multiply by 2. And then we have, what is it? 10x minus 2y equals minus 16. So at this point we can get rid of y, right? Now you may pause the video, try it yourself, and then compare it with my answer, right? But I'm going to go ahead now, right now. So basically we are going to add these two in order to eliminate them, right? So let me just show this. So we're going to add the equations. So we add equation 1 plus equation 2. Right, equation 1 plus equation 2. Okay, so 4x plus 10x, that gives us 14x, and plus 2y plus minus 2y, that gives us 0. Okay, so I won't write it down. 2 plus minus 16, that gives us minus 14. And now we can solve for x. So x equals to negative 1, right? The 14 is multiplying here, you move it to the other side, negative 14 there, so that negative 14 divided by 14 gives us negative 1. Okay. Then we can use this, x equals to negative 1, which is our x coordinate for the point of intersection, and we can substitute it into one of the equations in order to solve for y. So I would substitute it into equation 1. So sub x equals negative 1 into equation 1. Right? So what do we get? We're going to get the following. 4 times negative 1 plus 2y equals 2. Okay, so now this becomes negative 4 plus 2y equals 2. So negative 4 is subtracting, goes on the other side as addition. So we end up with 2 plus 4, that equals to 6, and then y is equal to 6 divided by 2, that gives us 3. So this is our y coordinate, and this means that the point of intersection Hope you guys can see that. Yes, point of intersection is -1, 3. Which means these two lines intersect at this point.